Hi everybody, this is Counting and Probability 12. I can tell you right now that the problems I want you to do will be written on the board, but I'm just going to put them here as well. Well, I don't know if I'll do that because I can't remember them, but the problems I want you to do should be between 13 and 18 on page 640, and I believe I assigned you 24 as well. So right around there is what you're going to do. Okay. So what I have listed here are 3 problems to do. It says a poker hand has 5 cards. And what I want you to do is find probabilities. And specifically, I want you to find the probability of getting a flush consisting of all clubs or getting 5 black cards in your hand, which could be clubs or spades. But to do that, you're going to have to do this first problem, which is, first of all, find the total number of 5 card hands. Then you'll have to count how many flushes, count how many black cards. Then you'll be able to find the probabilities. So let's give this a start. We're going to do letter A first. And what we'd like to do is we'd like to count those cards. And in letter A, I would like to do, first of all, in letter A, I just want to count the total number of 5 card hands. Well, what I know is a deck of cards has 52 cards. I'm going to choose 5 cards, and the question is does the order I get the cards matter? That's correct. The answer is no, the order does not matter, therefore this is a combination. And so once I've decided these 3 things, I know that the total number of 5 card hands is a combination of 52, choose 5. Which, if you push that on a calculator or you figure it out the long way, is 2,598,960. And so the next question is, what's a flush? So we want to count those. How do we count a flush? So a flush is all the cards are the same color. Now I've told you it's a club flush. So I'm already choosing the suit of clubs. Alright? And what I'm in clubs, there are 13 cards. And I'm going to choose 5 at a time because they all have to be a club. So I'm going to choose 5 cards. Again, this is a combination, so that's going to be 13 combination, choose 5, which will be equal to, as I figure it out, it'll be equal to 1,287 possible flushes based on clubs. Now there are also flushes for diamonds, flushes for spades, and flushes for hearts, and they'll all also be 1,287. So if you add those all together, 1,287 4 times, you get the total number of possible flushes. But right now we are worried just about how many club flushes. And then finally, we want to worry about getting black cards. And so we ask ourselves, how do I get a black card? Well, there are 26 cards, and I'm going to choose 5. And therefore, that's a combination of 26, choose 5. Alright? And that's also quite a large number. It's 65,780. And so we'll keep that, we'll remember that, and then we'll write it here in just a second. So now that we have all our numbers, we can actually find the probabilities. And so the first one is, what's the probability of a club flush? Well, the probability of a club flush is the number in the event, the number of club flushes divided by the number in the sample space, which is the number of 5-card hands. So that's going to be 1287 divided by 2,598,960, which should always be written as a decimal. And if I write it correctly, what I get on my calculator is 4.95 times 10 to the negative 4, which as a decimal is 0.000495, which is really quite a small probability of getting a flush. What's the probability of getting 5 black cards? So probability of 5 black cards. And by the way, this is, just so you know, this is how your work should look. You should show me this. Well, that's going to be the number of black cards, number of 5 black card possibilities over the number of 5-card poker hands, or the number in the event over the number in the sample space. And that is going to equal 65,780 divided by 2,598,960. And that's not quite as small a probability it should be 65,780 divided by, yeah, and that's about 2%, so 0.025%, 0.025%, which is a little better. Still rare to get all 5 black cards in out of 5-card hand, but certainly much less rare than getting a club flush. And that's why it's so hard to get really good hands in poker. It's just very difficult to get really nice hands, and flushes are one of the nice hands. So the next problems are similar problems. Suppose you're dealt 5 cards out of 52 cards, and suppose you want to get something like 3 red and 2 black cards. How do you figure that out? Well, what you have to do is you have to count these separately. And here's how you would do that. To get 3 red cards from the last problem we did, I know that's a combination of 26 cards, take 3 at a time. But to get 2 black cards, I know that there are 26 black, and I need 2 at a time of those. And so, to count 3 red and 3 black, you need to multiply those. And that'll give you the total number of 3 red and 3 black. If you want to find the probability of getting 3 red and 2 black, then you would divide by, say, a combination of 52 cards taken 5 at a time, or the total number of 5-card hands. Another issue you might run across would be what if you're not dealing 5 cards? What if you're dealing just 4 cards? Well, then your denominator wouldn't be a combination of 52 choose 5. It would be a combination of 52 choose 4. Okay? And you can split cards up not only into red and black, but you could split them up into aces and kings, or aces and jacks, and so forth. And so say I'm dealing 4 cards, and I want to know the probability of getting 2 aces and 2 jacks, then that means out of the aces, there are 4 aces, so I want to choose 2 of them. There are 4 jacks, so I want to choose 2 of those. Well, that's not all 52 cards like in the red and black. We can see that that's only going to be 8 total cards. So what do I need to add on to this? Well, I need to add a combination of the other 44 cards, and I'm choosing 0 of them. Now, from before when we did combinations, we know that that's just equal to 1, so it's sort of the meaningless part. But if I take the aces and jacks, the combinations of getting those, and I divide by 52, choose 4, that'll be the number of 4 card hands that give me 2 aces and 2 jacks. So I think you can do this assignment now. So I'm going to upload this one, and this will finish section 11.5. So 11.5 will be done, and I expect you to be able to turn that in on Tuesday. Homework, it should be on the board. If it isn't on the board, just do 13 through 18 and number 24. Do all of those. Okay? Thanks. We shall see you on Tuesday. Well, one more thing. Don't forget to watch video 13 for Tuesday so you're prepped for Tuesday. Okay, now I'm ready to go. Bye.